You've seen the photos. An astronaut standing on the moon, the lunar surface stretching out in every direction, pale and powdery and completely still, the Earth hanging in the background, impossibly blue. And above it all, a sky so black it looks like a wall. No stars, not one. You've probably noticed this. Maybe you filed it away as strange. Maybe someone told you it proves the whole thing was faked, shot on a soundstage somewhere in the Nevada desert, with Stanley Kubrick behind the camera and NASA pulling the strings. But the real answer is far stranger than a conspiracy. It's about light. It's about how cameras see, and it reveals something about human perception that most people never stop to question. Start with your own eyes. Walk outside on a clear night and give yourself 20 minutes. Don't look at your phone. Don't look at a streetlight. Just stand in the dark and wait. Slowly, one by one, stars will appear. First a few bright ones, then dozens. Then, if you're somewhere far from city lights, thousands. The sky will fill up in a way that feels almost overwhelming. Your eyes are doing something called dark adaptation. Your pupils widen. The cells in your retinas shift from cone cells, which process color and detail in bright light, to rod cells, which are far more sensitive to low levels of light. After 20 minutes of true darkness, your eyes become instruments tuned specifically for detecting faint light. A camera doesn't work that way. A camera has one setting for everything in the frame at the same time. And this is exactly the problem the Apollo photographers faced, standing on the lunar surface in the middle of a lunar day. The moon has no atmosphere. That fact matters more than almost anything else in this story. On Earth, the atmosphere scatters sunlight in every direction, creating the soft blue glow we call the sky. That scattering spreads light around so that even the ground in shadow receives some ambient illumination. Shadows on Earth are soft. Light bleeds into them. On the moon, there is no atmosphere to scatter anything. Sunlight arrives in straight, unbroken lines and hits the surface without being diffused at all. Where the sun touches the lunar soil, it is blindingly, brutally bright. Where a shadow falls, it is completely and absolutely black. There is no middle ground. Photographer and NASA researcher Gernot Riekert described the lunar surface lighting conditions as the equivalent of standing outside at noon on a cloudless summer day, not on Earth, but in a place where noon lasts for 2 weeks and the sun never moves, and there is nothing anywhere to soften what it does to the ground. So when Neil Armstrong and Buzz Aldrin set up their Hasselblad cameras on the surface of the moon in July 1969, they were photographing something in full, unforgiving sunlight. The lunar soil, their suits, the equipment, the lander, all of it bathed in direct solar radiation with zero atmospheric softening. To capture that correctly, to avoid a completely blown-out, overexposed white blur, the cameras had to be set for bright daylight conditions. A fast shutter speed, a narrow aperture, settings that would capture the lit surface without destroying the image with excess light. At those settings, the stars are simply invisible. Not because they aren't there, they are. Every star you've ever seen from Earth is hanging in that black sky above Tranquility Base. But stars are extraordinarily faint sources of light. On a properly exposed daylight photograph, they don't register. The camera's sensor or film is collecting light for a fraction of a second, tuned to handle the intensity of a sunlit surface. The light from a distant star is so much weaker that it falls below what the exposure can record. This is not a uniquely lunar phenomenon. You can test it yourself right now, tonight. Go outside after dark. Point your phone camera at the night sky. Notice that if you switch on a flashlight and illuminate your hand in the foreground, the stars behind your hand disappear from the phone's screen. Your camera automatically adjusts its exposure to handle the brighter foreground object, and in doing so, renders the faint background stars invisible. The stars haven't gone anywhere. Your camera simply cannot record both levels of brightness at the same time. Photography professor and light scientist Roger Clark calculated that to expose correctly for the lunar surface in sunlight, a camera would need settings approximately 1,000 times too bright to capture stars in the same frame. You would need an entirely different photograph, taken with a long exposure on a tripod in the lunar night, to see them. And here is the remarkable thing. We have those photographs. Astronauts on later Apollo missions did photograph the stars from lunar orbit and from the surface during shadowed periods. The Hubble Space Telescope, orbiting in the vacuum of space with no atmospheric interference whatsoever, photographs stars constantly, capturing some of the deepest and most detailed images of the universe ever recorded. Stars in space are absolutely visible, just not in the same frame as a sunlit lunar surface. The conspiracy theory collapses under the weight of a single question. If NASA faked the moon landings on a film set, why would the fake sky be accurate? A filmmaker trying to fake a moon landing would want stars in the background. They would be the most obvious detail to include. The starless sky isn't the signature of a cover-up. It's the signature of a correctly exposed photograph. There is something deeper in this story, though, something worth sitting with. We trust our eyes more than almost anything. We say, "I'll believe it when I see it." We treat vision as the gold standard of truth, but your eyes are not neutral recorders of reality. They are interpretation machines. They adapt, adjust, compensate, and fill in gaps constantly. Dark adaptation, color constancy, motion detection. Your visual system is always making choices about what to emphasize and what to suppress, based on what it has evolved to prioritize. A camera doesn't adapt. It is locked to its settings, and in that limitation, it accidentally teaches you something your eyes never would. Neuroscientist David Hubel, who won the Nobel Prize for his work on the visual cortex, spent his career documenting just how much of what you see is actually constructed by your brain after the fact, filtered through assumptions, predictions, and past experience. What reaches your eye is raw data. What you experience as vision is an interpretation. The stars are always there, above every city, every suburb, every brightly lit street, washed out by light pollution, invisible to the dark-adapted eye in an illuminated room, unregistered by a camera set for the foreground, but present, constant, unchanged. The moon landings happened. The photos are real. The starless sky is exactly what a correctly exposed photograph of a sunlit airless surface looks like, taken by cameras that could not do two things at once. What the moon photos actually prove is not a conspiracy. They prove that what you see depends entirely on what you are set up to see. Change the exposure and the stars appear. Change the adaptation and the universe reveals itself. You've been breathing tonight without thinking about it. And above you, whether you can see them or not, every star in the sky has been there the whole time. Just waiting for the right conditions to become visible.